Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young. Chapter 2, Projection Section Perspectivity, Elementary Configurations. Section 15, Configurations. The figures defined in the preceding section are examples of a more general class of figures, of which we will now give a general definition. Definition. A figure is a configuration if it consists of a finite number of points, lines, and planes, with the property that each point is on the same number A12 of lines, and also on the same number A13 of planes. Each line is on the same number A21 of points, and the same number A23 of planes, and each plane is on the same number A31 of points, and the same number A32 of lines. A configuration may conveniently be described by a square matrix. This 3x3 matrix has rows 1.2 line 3 plane, columns 1.2 line 3 plane. So reading by columns, it's A11, A21, A31. Next column, A12, A22, A32. Next column, A13, A23, A33. In this notation, if we call a point an element of the first kind, a line an element of the second kind, and a plane one of the third kind, the number aij with I not equal to j gives the number of elements of the jth kind on every element of the ith kind. The numbers a11, a22, a33 give the total number of points, lines, and planes respectively. Such a square matrix is called the symbol of the configuration. A tetrahedron, for example, is a figure consisting of 4 points, 6 lines, and 4 planes. On every line of the figure are 2 points of the figure. On every plane are 3 points. Through every point pass 3 lines and also 3 planes. Every plane contains 3 lines, and through every line pass 2 planes. A tetrahedron is therefore a configuration of the symbol by columns 4, 2, 3, 3, 6, 3, 3, 2, 4. The symmetry shown in the symbol is due to the fact that the figure in question is self-dual. A triangle evidently has the symbol, a 2x2 matrix, 3, 2, 2, 3. Since all the numbers referring to planes are of no importance in case of a plane figure, they are omitted from the symbol for a plane configuration. In general, a complete plane endpoint is of the symbol, a 2x2 matrix, columns n, 2, n minus 1, 1/2 times n minus 1. And a complete space endpoint of the symbol, a 3x3 matrix, columns n, 2, 3, n minus 1, 1/2 n times n minus 1, 3, 1/2 n minus 1, n minus 2, n minus 2, 1/6 n times n minus 1 times n minus 2. Further examples of configurations are figures 14 and 15 regarded as plane figures. Exercise: prove the numbers in a configuration symbol must satisfy the condition aij times aii equals aji times ajj for I and j equal 1, 2, 3. Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.